Okay, good morning class. So today we're looking at your cycle test you guys have written. It was for 50 marks and you had an hour to write. Okay. So the first question. We are told that in the diagram Km is the diameter of circle center O. So that means to say that OK and OM are equal, which is radii. OK is R, so OK is R, then OM is also R if needed. Okay. Then we are told that OC is 4R. Then we are told that angle C is equal to angle H. Must prove that EK is parallel to HC. Okay, so how do we prove that? We prove that by using the converse of the angles or the proportionality theorem. Alright, so what we know is that firstly OE is equal to R. Hey, go. Get down, please. Quickly. Get your change later. Okay, so OE is equal to RY because the fact that it's your radius. Okay. Now you see that angle C is equal to angle H, which is resolved in the fact that OC has to be equal to OH, which is equal to 4R. Okay. And some wrote angles opposite equal sides is actually sides opposite equal angles. Okay. So this of course is going to be 4R there. So that sets up, as you can see, almost the converse of the what's the name theorem, the prop theorem. So from here we can't go straight and say that OK over OC is equal to OE over OH. Can't go straight into that. We have to firstly say that OK over OC is equal to R over 4R, which is equal to 1 over 4. Now we say that OE is equal to OH is equal to R over 4R, which is equal to a quarter. Now we conclude since OK over OC is equal to OE over OH, which is equal to a quarter. Since that is the case, therefore KE has to be parallel to CHY because side divides, or line divides, absolutely, line divides triangle OCH in proportion. Okay, and that's how we get 5 marks in that subject. Okay, is there any confusion there? Huh? Alright, so let's go with the next one. Question 2. In question 2 we are told that intra-angle PQR, which is this triangle here, we know that A is the point on PQ such that PA is to AQ as 5 is to 4, or PA over AQ is 5 over 4. So what we do is just fill that in. So PA, which is 5K, and AQ, which is 4. Then we are told that B is a point on PR such that PB over BR is equal to 5 over 2. So PB, which is 5A, BR, 2A. Then we are told that AB is produced, AB produced cuts PQ, AB produced cuts PQ.
I think we just say PR.
So the AB produce cuts QR. Cuts QR. Produce that T. Okay, so both is stated at T. And S is the midpoint. S is the midpoint of AQ. Okay, so that's going to be 2K and 2K. Okay. So let's go to the first question pertaining this here. And the question we are asked to prove that AT is equal to twice SR. So AT this name here is twice SR. But if we can see that that is equal, so if we can prove that these lines are parallel, then we have done exactly that. Okay, which is the converse of the midpoint theorem coming into play. So we're going to prove that these lines are parallel. Yes, I must check your textbooks if it's covered in this period, please. At the end of the period. Okay, so we need to prove that these lines are parallel. Okay, so from here we can again see the converse of the proportionality theorem coming into play. Not so, because we have got 5 and 5K and 2K, and then we got 5A and 2A. So with that we can prove that those lines are parallel. So let's cover that quickly. So it's firstly intra-angle PQR. So what can we say? We can say firstly that AS is equal to SQ, which is equal to 2K. Why? Because it's given that S is the midpoint. S is the midpoint of AQ. Alright. So now we say, again we can't go straight into it, otherwise we're assuming. We have to first set up the grounds for the conclusion. So AB over BR is equal to 5A over 2A, which is 5 over 2. Then we have then we know that PA over AS is equal to 5K over 4K, which is equal to 5 over 2. Alright. So now we say since BP over BR is equal to PA over AS, which is equal to 5 over 2. Therefore, in conclusion, we can say PAB is parallel to SR. Not so. Why? Because line divides triangle PQR in proportion. Alright. So these lines are parallel now. Not so. But AB T is the same as AB, not so. So the whole line is indeed parallel to SR. I didn't have to write AB, I could have gone there and write straight AT. Okay? You could have said that there at that point as well. So now what you should see is the converse of the midpoint theorem coming up here, not so. So we can now say therefore AT has to be twice SR. Why? Because the converse of the midpoint theorem. The converse of the midpoint theorem. You can't write midpoint theorem, because we didn't prove that QR is equal to RP. Okay, and that's where I think one of you lost the mark here as well. You couldn't have said that. Alright. Any confusion at this point? Right, then there was the bonus question was linked to this question, yeah? Let's pull that up quickly. So now we are told, let's pull this around here. So now we are told that if RK is parallel to QX, okay, determine PX is to QT. PX is to XT, not QT. Okay. Okay, so from here we can see in this triangle, in triangle PRT, in this triangle. Don't mark it wrong, in triangle PRK. Okay, I can say that PB over BR is equal to PX over XK. Not so. So I'm going to say in triangle PRK. So what can we say? We can say that BP over PR is equal to PX over XK, which is equal to 5 over 2. Not so. Why? Because of the proportionality theorem with BX being parallel to RK. So I'm going to make this 5B and 2B. Okay. So now I have RK. Do I have RK? No, this is RK. Why did I do that? Sorry. PX. I have PX and I must calculate XT. So I still need KT. Not so. So now, you see these lines are parallel. Okay? And this side here is equal to this side here. Why? Because of this triangle's midpoint here. Can you see that, people? So let's go with that quickly. So in triangle AQT, again you don't have to say this, okay? In that triangle we can now say that QR is equal to RT. Okay? We already proved midpoint theorem here. You see that, people? And what is the reason here? Because of the converse of midpoint theorem. Again, people, we can't say midpoint theorem here because we don't know these lengths at this point. Okay, so converse of midpoint theorem. So that is going to be, so therefore, coming back to this triangle, we can say now that since that is the case and we know that XQ is parallel to RK, where did we get that? That was given to us. Again, that don't have to be said. We can now say that XK is equal to KT. And why is that the case? Which is 2B. Because of the converse of midpoint theorem again. Can't say midpoint theorem. So we're referring to one of the signs. Okay? The converse of midpoint theorem. Okay? So therefore, now we can now conclude that Px is to xt as now Px is 5b is to 4b, which in turn is 5:2. This question says no reason required, however show all calculations. So this is where I marked, you know. I gave you 1 mark there, 1 mark in conclusion. This no reason was given or marked there. Okay, and that's how I marked that question. Alright. Any issues here? Huh? Okay. The question paper and memo can be found in the description box below. Let's look at question 2. So here we are told, let me make this a bit smaller. Here we are told that in the diagram alongside, AB is a building, okay? B is the foot of the building, and the C and D are in the same horizontal plane. Okay, so assume that's the ground. Then we are told that C is the angle of elevation to the top of the building. The angle of elevation, of course, is X. Then we are told that BCD is 120. Then we are told that this angle here, which is CBD, is Y. And the distance between B and D is C meters. The question says, prove without the use of a calculator that B is equal to that thing. Okay, so where do we start? So we need AB. I start in triangle ABC. So we've got a triangle looking like this here. That's BACX. So we must use BC, so it's a link between the two triangles. So which ratio, a trigonometric ratio uses opposite and adjacent? Tan. So tan of x is equal to AB over CB. To make AB the subject of the formula cross multiply. So therefore AB is equal to CB tan x. Okay. That is the first part. Okay. Now in triangle CBD, in this triangle here now. Okay. And as you can see, it's 60 minus y. We need to pick this one up and we need to pick that up. That's the opposite. So in other words, we need to calculate angle D to use the sign rule. So angle D is going to be sum of triangles, which is 180 minus 120 minus 1. Alright, so that would simply be 60 plus y. No. We're going to leave it like that until I take it to sign. I can reduce it. Okay. It had to be plus 1. Sorry?
120 plus
180 plus 1.
120 plus 1 and you bracket
120 plus 1. Oh. Sorry, I made that, yeah. So absolutely, so that's going to give you, thank you. So 60 minus 1. Okay, so we can now go with sign. 60 minus y over. That is now 60 minus y. So it's going to be opposite, which is CB is equal to sine of 120 over C. Now we make CB the subject. Cross multiply. So C sine 60 minus y is equal to CB. Now this can be written as sine 180 minus 60, which takes you to quadrant 2. So sine is positive, so I divide by sine 60 both sides. So that of course cancels. So CB is equal to, now sine of 60 for your special triangle. So it's 31, 2 root 3. The sine of 60 is root 3 over 2. Okay, so that's going to be C sine 60 minus y over root 3 over 2. So what I do is, wherever I see CB now, I'm going to replace it with that story. Okay. Which now gives us therefore AB is equal to, CB is going to be C sine 60 minus y over, now this can be divided by root 3 over 2, which is multiplied by 2 over root 3 tan of x. Okay, and that is exactly what they want to do. 2c tan x sine 60 minus y over root 3. Okay. So in the next question, we are told with regards to length, we are asked to determine the length of AC. To determine the length of AC. So if we look at what we have now, we actually need that thing. So if we're looking at AC, AC is in this triangle. Okay? If it's further given that C, so I got C, which is 12, I got X, which is 40, and I got the Y, which is 45. So in other words, from here, from the offset, I can actually calculate AB. Not so. So AB is equal to 2 times 12 tan of x, which is 14, times sine of 60 minus y, which is 45, and this is all over root 3. So I put that in the calculator. You put that in the calculator, it's simply 2 times 12 tan 40 sine 60 minus 45 over root 3 comma 0 1. That's 3,01 meters. Okay. So remember, what do they actually want? They actually want AC. So x, I know it's 40 degrees. So I have a triangle looking like this. So there's 40. That is 3,01. That's your 90. And you must calculate the hypotenuse here. Not so. So which trigonometric function uses opposite and hypotenuse? So I now say sine of 40 equals 3,01 over AC. You cross multiply. That now gives you AC is equal to, well, AC sine 40 is equal to 3,01 divided by sine 40 both sides. So 3,01 over sine 40. Okay, so that is answer over sine 40 gives us 4,68. 4,68 meters. Any issues there? 4,68 or 4,69 if we had rounded that off. Okay. Let's go to question 3. In question 3 we are given, determine the limit as x approaches 2 of x cubed minus 8 all over 2 minus x. People, if I substitute that straight, you're going to give me an undefined solution. So that's going to go the limit as x approaches 2 of x minus 2, that factorizes into difference of cubes, is x squared plus 4x plus 2x plus 4 over, swap that around, x minus 2. So that can cancel. It now gives you, if I say x, I put it 2, so it's 2 by 2 by plus 4 over negative 1 so that gives me 4, 8, 12, so it's negative 12. Okay? Go with the next question. The question says differentiate from first principles. We know he's going to use the formula f prime x equals the limit as x approaches, or h approaches 0, sorry, of f of x plus h minus f of x, and this all over h. So if f of x is equal to negative 3x minus 5x squared, then f of x plus h is simply negative 3 into x plus h minus x plus h all squared. Alright, so I'm going to do my first step in cancelling there as well in one time. So that would give me negative 3x minus 3h minus 5x squared minus 10xh minus 5h squared minus open brackets negative 3x minus 5x squared. Why do I put that in the bracket? More than one term following a negative sign. So that's all over h. Multiply this in, I will get positive 3x cancels negative 3x, and positive 5x squared cancels negative 5x squared. As you can see, h is a common factor here. Although negative is as well, I don't worry about that. So it's going to give you negative 10x minus 5h all over h. Of course, the h is cancelled, and that's what we want. Wherever we say h, we put the 0, of course. Drop this limit, so it's negative 3 into negative 3 minus 10 x. And we knew that from the offset already, that's going to be negative 3 minus 10x. Okay, but because it's first principles, we have to go with that story. People, the 3.3.1, differentiate the following function, expressing your answer with positive exponents. When necessary, pay careful attention to notation. Alright. So firstly, we need to get this in the form of ax to the exponent n to apply the derivative. So we're going to write from third to exponential form. So it's 6 times x to the 1 over 3. Apply my derivative. So dy over dx is equal to 6 times a third is 2. Minus 1 gives you negative 2/3. This is negative exponent. Bring that down. So it's 2 over x to the 2/3. Okay. Next question. The derivative with respect to x of pi x cubed minus x to the pi. People, that's already in the form of ax to the exponent n. So I apply my derivative, I drop the d. So 3 pi x minus 1 is squared. Pi times negative 1 is negative pi x minus 1 will be pi minus 1. That's all I wanted for 2 more. Some of you converted to decimal, which is also fine for me. People, number 4, we are given calculate the intercepts of g with the axis. Show all calculations. People, how do you work out the y-intercept? We left x equal to 0. So that's going to give you g of 0, which give you an answer x. So that's my y-intercept. X-intercept, let y equal to 0. So I needed to test for factors here, but g of 2 gave me 0, not so. Alright, so what you have to do is you have to say 2 cubed minus 2 times 2 squared, which cancels already, minus 4 times 2, which is 8 plus 8 is also 0. So we conclude, therefore x minus 2 is a factor. Alright, so now we now say that g of x, of course, is equal to x minus 2 into. So x multiplied by what is? X cubed. X squared. Negative 2 multiplied by what is positive 8? Negative 4. So what do I add here? Plus kx. Okay, so that is going to give me negative 2x squared, and this is going to give me kx squared. So I say negative 2x squared plus kx squared must be equal to negative 2x squared. That of course cancels, give me kx squared is equal to 0. Therefore k is equal to 0. So if k is equal to 0, then g of x now reads g of x is equal to x minus 2 into x squared minus 4. Difference of 2 squares, so it's x minus 2, x minus 2, x plus 2. So x is equal to 2 or x is negative 2. Okay. So we got all our intercepts now, x and y intercept. The next question says determine the coordinates of the turning point of G. How do you calculate the turning point? First derivative. What was g of x equation? G of x was equal to x cubed minus 2x squared minus 4x plus 8. If I apply my derivative there, I'm going to get 3x squared minus 4x plus 4. I see that equal to 0, solve for x, so x is negative 2 over 3, or x was equal to 2. Correct? So what do? I need to find the corresponding y value. How do I do that? By subbing negative 2 over 3 into this equation here. So it's negative 2 over 3 cubed minus 2 times 2 over times negative 2 over 3 squared minus 4 times negative 2 over 3 plus 8 give you an answer of?
256
Sorry?
256
256 over 27. So this point was negative 2/3 and 256 over 27. On the other end, we have g of 2, which is 0. So that is going to be 2 and 0. Okay. So now, I ask you to sketch this graph. Okay, so we have the turning points. The y, so it's negative 2/3. And it turns on this line at 256 over 27. Then at 2, that's the turning point there as we know. And this was negative 2. And this was your 8 that we calculated. You all agree with that? Let's look at 4.4. For which values of x will g be concave down? So concavity is dependent on your second derivative, not so your point of inflection. If you calculate your point of inflection, what do we get? G double dash of x is equal to, that's my first derivative, apply a derivative, I'm going to get 6x minus, you all agree with that? 6x minus 4. The second derivative, then what do? We see that equal to 0. We see that equal to 0, we drop that. So x is 2 over 3 or 4 over 6. Now that point is approximately here, not so. This is x is equal to 2 over 3. So this part of the graph is concave. Down or up? Down, it's concave down. So they ask you for concave down. So x has to be less than 2/3. Okay. And the last question was with regards to the tangent. The tangent at x is equal to 2. Now a tangent is basically the straight line that cuts the graph at one point only. So if you're looking at the tangent at 2, it's actually this line here. It's actually the x-axis. So what's the equation of the x-axis? Y is equal to 0. The question paper and memo can be found in the description box below. Is there any problem with the marking?